All right, good afternoon, everybody. Afternoon, good to see you guys. Okay. Well, let's label these first since I got them up there. What do we got? What's A? Fiber cartilage, okay. What's B? What is it? What'd you say? Dense regular, yeah, absolutely. That's dense regular connective tissue. Okay, what's C? Throwing you guys off. Having the same one on there twice. There's your hint. That one's fiber cartilage too. Yeah, so there's a couple different versions of fiber cartilage. Yeah, so that's a more zoomed out version of it. Okay, you don't see quite as as much waviness as you would with the dense regular, and there's a lot more cells than there is with the dense regular. Okay, and then what's D? Elastic cartilage, we got that one, and then E. Density irregular, yes, that is density irregular. So much more wavy, not parallel fibers, but that's density irregular. Okay. All right. Yeah, so a couple things for the rest of the week here. So obviously today, your lab quiz, okay, on the axial skeleton here. So studying all those skull bones, all those, yeah, is including the bones of the thorax, right? The ribs, the sternum, all those ones that you guys looked at last week in lab. Okay, and then today's your last chance to get your hands on the bones and to study them that way. And then next week we'll have your practical. Okay, so the way that the practical works is, again, you're just going to do it at the beginning of your assigned lab time. Okay, and then you will finish that, go out, and then come back in. You're not done with the lab yet for that day. You'll come back in and start the cat dissection process. So you want to have your dissecting kit with you, have the clothes on that you need for that. And you're not allowed to bring your backpack into the lab during the practical portion. So you just want to bring something to write with and an eraser, pencil, definitely, an eraser. And then you can put your bag. There's like a little section of cubbies right there, kind of in the middle of the ladder and Seder. All those black cubbies there. You can put your bags over there during the practical. That's the setup. Okay, so that'll be next week. Go ahead, Maddie.
That class last year said that she had to like sign up. Are we not doing that anymore?
That's not for the bone one. Yeah, for the muscle one, we'll do that. Yeah. So for the muscle practical, we do all 8 sections on the same day on a Tuesday. So that's the one you got to sign up for because it's not during your specific lab time, but bone one happens during your lab time. So you're good. Yep. Yeah. Okay. So that's the lab setup. Any questions on lab? What's going on in there? Okay. And then, yeah, so exam number 2 on Friday, right? It turns out they're not going to let dogs in the building at all anymore. So no Betsy this year. So yeah, sorry about that. It was always one of the favorite things that for exam days, but they're not letting us do it anymore. Betsy is about as calm of a dog as you could ever imagine. They were worried about safety issues, but yeah, just had to apply that policy for everybody. So that, and I'm actually having somebody else proctor the exam on Friday. Okay. So just so you don't be totally surprised when you see that I'm not here. Tara Bowles, our department assistant, will be here for the proctoring part, but yeah, again, if something happens on Honor Lock, I can't really help you anyways, right? It's just a matter of you getting on that chat and figuring it out. If you've updated your computer or something like that, again, I would probably go on and do that practice quiz ahead of time, so you don't have to mess around with that during and you can take that practice quiz over and over again as many times as you want. But yeah, so that'll be the case for Friday. Okay. All right. Any questions about that or anything else in the class before we get going? Okay. All right. So okay, so today we're continuing on with the skin, the integumentary system, and today we'll kind of talk about appendages of the skin, so different things that come off of the skin, and then we'll talk about kind of injuries to the skin cancer, a few other pathologies like that. So don't peek ahead too far if you just ate lunch, but we do have some kind of nasty pictures at the end of this of these slides to show some skin injuries. But yeah. Okay, now everybody's peeking ahead. I don't know why I said it that way, but let me close this door. All right, so we'll talk about the appendage part first here. So these are the ones we'll talk about. Okay, hair, nails, oil glands, and sweat glands. Okay, so starting out with the hair. All right, so there are definitely quite a few functions of our hair outside of just looks or warmth. Warmth is one of them. Okay, but then obviously, not obviously, but there's the protecting it from insects. And this one's kind of interesting because our touch receptors in our skin typically aren't activated with just the weight of an insect by itself. And so like certain times, like when a fly lands on your skin, like in a spot you don't have hair, maybe on the anterior side of your forearm, you might not even feel it. But if it steps on a hair, then it kind of uses the torque from that hair being like a lever that kind of pulls on it. And then there's touch receptors in your hair follicles and you can feel it. So that's part of it. Very protective of our head with physical trauma, as well as heat and sun. Okay, eyelashes can definitely help to shield our eyes from the sun, right? And even those pesky nose hairs have some functions too, catching and filtering things that we're breathing in, right? As well as insects. Okay, a few more things about hair here. The shaft part is the part that we can see. It's called the shaft. That's a visible part of the hair. Okay, this is made up of hard keratinized cells. So there's different types of the protein keratin in the body. There's the softer type that we find in our skin, and then there's the harder type that we find in our hair, in our nails. So this is hard keratin. The root of the hair follicle is the part where the new cells are constantly being added. So we have a version of those basal cells there that are just constantly making new cells, adding it to the hair shaft. Okay, texture is going to be dictated by the shape of the shaft, right? So you can see that there. So straight hair is pretty much round. And then the flatter it gets, kind of the more curly it gets, right? So wavy is a little bit more oval-like, a little more oval-like, it's curly. And then very spiral or coiled hair is almost like flat. Okay, so different. And you can kind of see that in a microscopic image here of round hair versus flat hair. Okay, color is dictated by the amounts and different types of melanin, because melanin is that pigment protein that our melanocytes put into our skin, but there's different types of it. Okay, red hair is heavy in iron, and that's why it shows up as red. Our middle child is a redhead. We weren't expecting that, but it's kind of redheads are a little bit actually on the decline. Maybe some of you guys have heard about this before, because it's a recessive trait that needs to become from both sides. There's like these predictions that show redheads might become extinct at some point. I'm sorry, the couple of you that are redheads, but I say that too. We joke about our son with it too, but we're about that too. Our son. But yeah, sometimes people see when he was a baby and they would see this bright red hair in a baby, they would just kind of get super excited, oh, this is a rare thing. There were people in the grocery store that would talk to us about that. But did any of the redheads ever get reactions like that? Yeah, I get some of that. Yeah, for sure. Yeah, so it's kind of funny. But gray hair is also kind of interesting. Gray hair is when the melanocytes are not functioning properly anymore, and they are still making little vesicles that are supposed to be full of melanin. And then they put that into the cells in the hair, but they're not full of anything. They're actually just full of air. So it's actually gray hair is just like these little bubbles that are in the hair instead of having the protein. And so it just kind of looks almost clear like is kind of what gray is, but not exactly. So yeah, and then split ends, you can kind of see this right here. It's just kind of this fraying of the keratin fibrils at the end of the hair. Yeah, okay, yeah. I have a solution for today. So yeah, so I think I'm just recording the screen of the USB video. So but that's definitely
something back
yeah,
there,
you
Will?
can, yeah. So yeah, so that's a bit on hair there. Questions on any of that so far? Okay. Yeah, so a couple other things about hair. So we have two primary types of hair on our body. So vellus hair is kind of what you think of as peach fuzz, right? So short, fine, unpigmented hair. Okay. Pre-puberty, this is most of the body. Post-puberty, still dominant in women, but then a lot of those types of hair shift over to terminal hair, which is called coarse hair after puberty, especially in males. And these are longer, pigmented, and testosterone has a lot to do with switching these hair follicles over from being the vellus follicles to the terminal follicles in puberty. Okay. Yeah, and so this is just kind of a cute little cartoon that it kind of explains the hair growth cycle here. So the cycle times can kind of vary, but pretty much each hair follicle is on a different pattern. And so a hair follicle will kind of start to grow nice and thick, but then shortly after it kind of reaches its maximum length, then it'll start to kind of thin out from the bottom, start to degenerate, and then the growth stops completely, and it'll stay kind of at that certain length for a little while. Okay, but then eventually that old hair falls out, right? But then there's usually a period of time where there's no hair coming out of that follicle at all. Okay, and so that for eyelashes, that they rest about 105 days between sending out a new piece of hair. The scalp hair follicle is about 1 to 2 years. Okay, so luckily they're not all on the same schedule for us, right? Because then that would mean we would be bald for a year or two, and then it would all come back, right? So they're all on a different time frame there. So yeah, but those hair follicles on average grow for about 3 years before they get into the kind of their rest period. There's a little baby hair with this binky getting ready to come out eventually. So yeah. So yeah, male pattern baldness is when the hair follicle itself is just lost. It just doesn't function anymore. And this is connected to testosterone levels. There's definitely a genetic basis of this. Who do you look to in your family to see if you might be bald? You guys know? Yeah, your mom's dad, right? Your grandpa on your mom's side for sure, right? So some of you guys are thinking about what that guy looks like. Does he have hair still? Could be in trouble. Yeah. My kids are in trouble. Unfortunately, my wife's dad was already like almost bald when he was like 21 years old. So it's not looking good for our boys, unfortunately. But yeah, so kind of sad. Yeah, it's rough, right? Yeah, totally. Yeah. So bald can be okay though too, but yeah, so that's it. So and then the other thing is the remaining follicles typically kind of shift back to that vellus hair, so there's kind of like a softer, finer hair on the head, but those long thick follicles aren't producing anymore. So questions on any of that?
Could hair fall out? It's like a deficiency too in something, or just genetics?
Well, it can definitely fall out because of like certain types of environmental exposures for sure, definitely like with chemo and things like that. But as far as, yeah, I think kind of more extreme nutritional deficiencies could cause things, but not typically from just like a minor deficiency in something. Yeah, that kind of what you're wondering. Yeah. What other questions on hair? Okay. Sometimes I just get hammered with questions on hair. So I've done lots of research on things. The girls usually get super excited about it, but you guys aren't asking many questions today. So that's okay. All right. Maybe nails. Maybe I have some nail questions. Okay, we'll see. But yeah, so with nails, when you think about your fingernails, we don't really think about how important they are until maybe we need to use them for something. And for example, they do really protect our fingers. I noticed this sometimes when I'm cutting up an onion or something and I slip and the knife hits my nail instead of my finger. I'm like, oh, I'm glad I had that nail there. I would have just chopped my finger off, right? But then also they're tools, right? We pinch things with them, we grab things with them. They give us some ability to kind of have that fine point pinch. These are very heavily keratinized cells, so the hardest type of keratin that we have. Interestingly, our fingers and our toenails are on different growth patterns. Maybe you guys have noticed this, that you have to clip your fingernails more often than your toenails, right? Fingernails grow about 3 times faster than toenails do. So, okay. All right, so a little bit about the glands that we find throughout our skin. So the first type are called sebaceous glands. Okay, so sebaceous glands are the ones that produce more of an oily, lipid-rich mucus. Okay, the secretion mechanism, remember we talked about those different secretion mechanisms. They primarily use that holocrine one, right? And again, that meant that the whole cell inside that gland just kind of falls out, and that's what gets secreted. Since cells membranes have all kinds of lipids in them, right? This tends to be a very lipid-rich as well as protein-rich mucus that's released. Okay, these glands are directly stimulated by testosterone. Okay, this is very important for waterproofing our skin, provides some protection against bacteria, as well as softens our skin, keeps it somewhat moist. Okay, all of the ducts of sebaceous oil glands are connected to hair follicles. Okay, so they're always connected to hair follicles. We don't always know that because that hair follicle might be in a rest period, right? When a zit comes out. We'll talk about zits in 1 second. But yeah, so we don't find these in our thick skin, but we have lots of them on our face, neck, upper chest, upper back as well. Okay, so really what acne is an infection inside of the hair follicle because of clogging up that little pore where the hair follicle was coming out. Okay, so we can kind of see this here. This is the way it's supposed to work, right? Where we see that oily secretion. Okay, there's some issues in there. All right, thanks, Kevin. Appreciate it. Yeah. Yeah, so what we see here, we see this is what is supposed to be happening. That oily secretion is supposed to be able to just kind of squirt out freely. But when that hair follicle gets clogged up, right, we keep secreting that stuff out, which then builds up some pressure, but also that makes a perfect place for bacteria to grow. So we get a little infection in there. And really, that's what a zit is, right? That's what acne is. And so, yeah, so you build up enough pressure. Obviously, it kind of creates that redness underneath. And then you can pop it like we've probably all experienced, unfortunately. But yeah, so then that pus that comes out is really just dead cells from our immune system that were there to kind of attack the bacteria that was inside. And that's really what that pus is. So, okay, those are sebaceous glands, and the connection with testosterone there, stimulating it, is why so much of this picks up, at least in males, but also in females, with puberty, is because that's when testosterone levels spike in males, estrogen levels in females, and estrogen is partially related to stimulating these glands as well. So you get a lot of extra production, so more likely to clog up. Okay, questions on any of those? Okay, so then our primary sweat glands are called our eccrine sweat glands. And these, we have a lot of these, around 2.5 million of these in our skin. Okay, and this is actually something that sets us apart from other animals for the most part. So animals like horses, most like four-legged animals, do not have this type of sweat gland. Okay, they only have the next type, which we'll talk about on the next slide, which is the apocrine ones. And so these ones are our primary source of cooling in our body when we're exercising. Okay, so their secretion is almost all water, a little bit of sodium, and some other salts. Okay, this is the merocrine type, and their role is purely temperature regulation. Okay, and we talked about how this happens already, right? But we need to get that water onto our skin, and then what needs to happen to that water to help us cool down? It needs to evaporate, right? Because then the energy that it took to change that water from liquid to vapor is taken from our body, right? And that's what cools us down. Okay. Just to kind of make this hit home, there's a whole type of hunting that's done like on the plains of Africa called subsistence hunting. If has anybody ever read the book or heard about the book Born to Run? Heard of that, or you've heard of subsistence hunting? Yeah, so it's this idea that certain tribes in Africa hunt animals like elk and things, other deer type animals, and those animals are way faster than them, right? There's no way they can actually run faster than those animals, but humans always have better endurance than those animals and have better ability to control their temperature, so they can pretty much just chase them at a pace that they can keep up for hours and hours and hours, even days on end, until the animal dies of heat stroke, right? And that's really what subsistence hunting is the animal will push themselves as far as they possibly can because they're afraid for their life, but they don't have the ability to cool themselves down like humans do. So they literally just die of heat stroke. And that's really the method that's been developed over years. And it's because one of the primary reasons is because we got all these eccrine sweat glands and they don't. So, okay. So yeah, so one interesting kind of just note is that the secretion actually comes out in the dermis, right? So then it's just kind of like the water just kind of squeaks through the epidermis through little cracks, as you can see there, right? It doesn't the duct doesn't come all the way up, and they're not connected to hair follicles. And we have the highest concentration in places like our palms, the soles of our feet, our forehead, places that we can tend to get pretty sweaty. Okay, and then our last type of gland here is the apocrine sweat glands. And this is the type of sweat gland that the other animals do have. So horses have these, all those types of animals have these. They're much less abundant. We only have around 2,000 of them. Okay, these are mostly found in areas like our armpits or anogenital regions. Okay, and their secretion mechanism is merocrine as well, but they don't just release water. They're also that sweat includes some proteins, some lipids as well, and these are associated with hair follicles. Okay, and their function is to protect from bacteria. But this is where body odor comes from for the most part, is from these glands, because the proteins that they secrete, the bacteria on our skin degrades that, and some part of the byproduct of that bacteria eating that protein is some smelly gases that are released from that. And so this is where most of the body odor comes from, as these apocrine glands. Okay. Questions on any of those glands so far? Okay. All right. And then just a couple specialized glands. The ceruminous glands are kind of a different version of apocrine sweat glands, and they produce a very thick, waxy secretion. Any guesses on where we find those? Ear, exactly, right? These are what produce earwax, okay, our ear canal. Okay, this is helpful for protecting our ear, as well as catching particles of something, or even insects that might be crawling down our external ear canal. And then mammary glands are a modified version of a sweat gland, obviously produce milk. Just kind of the amazingness of these glands is milk. Breast milk is known as like liquid gold. And so in many ways, we can reproduce the nutritional value of milk with formulas and things like that. But one of the amazing parts about milk is it also contains immune system components for the baby too, right? So much so that the immune system components actually change on an hourly basis, depending on what the mom is exposed to. And so, for example, when a mom is breastfeeding and she's fighting a cold, obviously that baby's going to be exposed to that same cold, but mom's already starting to produce antibodies against that virus inside of her. That goes into the milk, and then baby gets those antibodies. And so there's a good chance that the baby won't ever get that cold, because the baby's directly getting immunity for that exact virus that the mom's fighting at that time. And breast milk is constantly changing as the baby grows too, right? Just like formula does, you buy different ones for different ages. But yeah, even when a baby's first born, the breast milk that comes out in the first couple of days is completely different than it comes out in the next 3 and 4 days, and it's just constantly changing throughout the lifespan of the baby. So it's really an incredible thing that the body produces. Yeah.
Are mammary glands in both men and women?
Yeah, there's a very kind of underdeveloped version in males, and actually under certain conditions, males mammary glands can grow and start producing milk in some kind of abnormal conditions. But in general, yeah, they're there, but they're not really activated to do much. Yeah. Yeah. So one of the side effects of excessive testosterone use is breast growth in males, and doesn't always happen that it produces milk, but breasts are grown in males at times, because some of that excessive testosterone gets converted into estrogen. So yeah, but yeah, very, very rare for a male to produce milk, but some of the same equipment is there. Yeah, good question. Other questions on that? Okay. All right. Go ahead and talk about this question with the people on your team here, and answer it when you're ready.
Oh, wait, no, it says 1 year. Yeah, so it has to be.
What's that? Yeah, did it not start? Should work. Oh, yeah, it did work. Okay.
Oh, yeah.
Right, no, no. You're right.
Okay, okay. I just thought. Oh, got it. So that helps, like.
All right, so you're putting in all the answers that you think are correct. I think I did this one slightly differently. I think you can just press enter buttons, both of them. Does it work that way? Yeah. Okay. Might be easier than the other short answer type question. All right, maybe everybody just hit send to make sure. I've only got 38 there. There we go. That looks better. Good. 45. Okay, that's everybody. All right, so most of you are saying both A and D, but then some of you are saying B and C, and some are saying E. So let's just talk through each one. So A, vasodilation of blood vessels in the dermis when we are hot. Okay, so we talked about this a little bit, right? That we can open up blood vessels in our dermis, the second layer of our skin, send that blood there that got hot because it got warmed up in our core or next to our muscles, and then that can help us radiate out heat. Okay, so that's definitely true. Okay, we wouldn't vasoconstrict those vessels because then that would limit the blood coming to that area, right? Vasodilation allows for more blood to come to that area. Okay, why is this one not right? Why is C not right? No blood vessels there at all, right? We don't have blood vessels in the epidermis. Okay, and then yes, primarily our eccrine sweat glands are the ones helping us do this. Not so much the apocrine, definitely not the sebaceous, and definitely not vasoconstriction, definitely not in the epidermis. Okay, so A and D, correct. All right, so vasodilation means to make blood vessels bigger. Vasoconstriction means to make them smaller. When we want to send more blood to an area, we vasodilate to that area. When we want to send less blood to an area, we vasoconstrict to that area. Okay, questions about any of that? Okay, all right, so we're going to transition into looking at some different pathologies of the skin. Okay, we'll start with skin cancer. So skin cancer is a very common type of cancer. About 1 in 5 Americans develop some form of skin cancer. Okay, that's a lot. So that's 1 in 5, 20%. Right. So how many people in this class at least have like somebody in their immediate family that's had some run-in with skin cancer in some way? Yeah, looks like about 20% of the class, or even a little bit more, right? And so, but a lot of that, the vast majority of that is the benign type, right? Which just means it's a little bit of a tumor, right? It doesn't spread, it can be removed, and it's done, right? That's the vast majority of it. Malignant means that it spreads throughout the body, right? And that's the kind that is problematic, right? Could end up in your lungs, can end up somewhere else, right? And then grow tumors there. If it's caught too late, then it's just too hard to track down all of it, right? And so most of it is benign out of all these cases. Okay, so risk factors for this, obviously sun exposure, fair skinned, and then just age, right? Older than 50, chances of skin cancer goes up quite a bit. Obviously with sun exposure, sunscreen usage is a huge part of that as well. Okay. Okay, so the 3 primary types that we'll talk about are here. Okay, and they're named kind of based on the cells that are affected. Okay, so basal cell carcinoma, right? So the location that we find that is, it's called the stratum basal, but really that's those basal cells in the bottom of our epidermis, right? Remember those ones that are constantly making new cells in that basal layer of our epidermis? It's those ones, right? And it's more likely for cells that divide a lot to have cancer anyways, because they're constantly divided, right? And they're constantly doing DNA replication, and there's a chance that there's a mistake in that DNA replication every time it happens, right? So the stratum basal is the ones we're talking about there. It's those basal cells, basal cell carcinoma. This is 80% of those skin cancer. Right? So this is a lot of them, right? Most of the time, this doesn't metastasize. It doesn't spread throughout the body, doesn't become malignant. It's just a little tumor, can be removed. So 99% cure rate. This is kind of what one of those little tumors might look like. Okay. Then there's the squamous cell carcinoma. Okay. This is also the keratinocytes. These are also keratinocytes as well, right? But just a different layer. So squamous cell is just a little bit, stratum spinosum is just a little bit up from those basal cells. Okay. Not quite at the bottom, but a little bit up. Right. So these can grow pretty rapidly, and they can spread if it starts pushing its way down into the dermis. And sometimes these tumors can push their way downwards into the dermis where they find a blood vessel. And then if those cells can get in the blood vessel, they can circulate through the body and end up somewhere else. Okay, second most common, but also very high cure rate here. The bad one that we're very worried about always is malignant melanoma. Okay, this is from the melanocytes. Right, this is not the keratinocytes like the other ones were. This is the melanocytes, the ones that are making that melanin protein, putting it into the other cells. Okay, about a third of them are from moles that people already have on their skin. Okay, very high malignancy rate. About 5% of skin cancers fall into this category, and there's about a 30% survival if it's already spread far out when it's detected. Okay, so that's not a good survival rate, right? 30% survival rate is pretty bad. So this is a serious cancer, but this is one that if it's caught early, then it can be dealt with. But if it's not, then a lot of times it's already spread to multiple locations throughout the body by the time it's caught. But there is a lot of progress on different immunotherapies and different things that can actually deal with this after it's been, even after it's spread some. So we're doing a lot better here. This used to be a 99%, I think it was a 90% death rate. Now it's closer to 70%. So it's definitely better than it used to be. But yeah. Okay, so this is just a little infographic about melanoma, ways to kind of detect when you see that mole on your skin. Obviously, not every mole is melanoma, but here's a few ways to kind of look and see what might tip you off to at least go get it checked out. Okay, number one would be, is that mole asymmetrical? Right, one half kind of looks one way, the other half kind of looks the other way. It's not, doesn't have symmetry. If there's the border integrity is kind of impaired, so it's kind of like unclear, like kind of undefined edges to the mole. Okay. And then multiple colors within the mole is definitely not a good sign as well. And then having a little bit larger diameter, greater than 6 millimeters. Okay, so if we look back on this one, we can kind of see that, right? There's multiple colors in it. There's kind of blurring of the edges around the mole. It seems to be larger. We can't really tell because we don't have a point of reference. But yeah, it's not symmetrical, really. Okay. All right, questions on that at all? Okay, go ahead, answer this question here. Talk with the people on your team. All right, about 15 more seconds or so. Check with the people on your team. Make sure you're on the same page and go ahead and send it in. Okay, all 45 of you. Out of the 45 of you, 3 have the correct answer. Okay, look back on your notes and see where you find these different types of cells. Which layers of the skin do we find these types of cells? I'm just gonna leave it open. You can change your answer if you want to. Oh, okay, thank you. All right, few of you changed your answer, but it looks like everybody still voted. So yeah, so it's E, right? All those are in the epidermis, right? All of those types of cells are in the epidermis, not in the dermis. Okay. All right. Okay. So we're going to transition over to different types of burns. Okay. So first, I should have warned you before I put that one up, but first bad picture there. That's a burn from a high voltage line. So an electricity burn. Typically with electrical burns like that, there's an entry wound and an exit wound. So that would, I'm sure, have been the exit wound. The exit wound is typically worse. It kind of just can tend to kind of blow out part of the tissue as it exits the body. But definitely pretty nasty there. Okay, so all different types of burns, right? All different types of things can cause burns. All of those different things there. But we'll talk about kind of the degrees of burns, and then we'll look at some other skin injuries as well. Okay, so first degree burn really just involves the epidermis, right? So just that first layer of the skin, that epithelial tissue. Okay, it may get kind of right almost down to the dermis, but doesn't really involve the dermis. So it's really just the epidermis that's dealt with. So the skin is very red and dry, and this one definitely hurts a lot, lots of pain. All those nerve endings are still intact for the most part, so it hurts a lot. Okay, there might be some swelling around it as well, and that's a superficial burn. So you can see kind of on the image which layers are damaged there. Okay, and then there's a second degree burn, which is known as a partial thickness burn, which that's going to include the whole epidermis as well as part of the dermis. Okay, so there'll be intense blistering with a second degree burn, and then considerable swelling as well that occurs within 2 days, 48 hours. Okay, the skin can kind of be spotted around the really deep part, so you typically will have first degree burns around the deeper second degree burn portion, and that kind of looks spotted. And this one is very painful. Sure, you can see it's not really getting into the underlying tissues, just the epidermis and the dermis, not really into the lower tissues yet. But then when we get to a full thickness burn, this is a third degree burn, which damages all the layers of the skin plus lower layers of tissue as well. So fat, muscle, even bone at times can be damaged, nerves. Okay. Sometimes it's difficult to distinguish from second degree, but a lot of times there is kind of this charring look to the skin that we see here for sure. And yeah, and sometimes there's not really much pain involved with this because the nerves are just gone, right? There might be pain around the very edges where there's more first and second degree burns, but on the deeper part, it doesn't necessarily inflict much pain to start with, at least. So yeah, so the biggest thing that we're worried about with burns, number one is the person going into shock, right? Because the reason for that is because we go into shock when we don't have enough blood flow to our vital organs. That's really the common thread of all types of shock, is decreased perfusion to our vital organs. Okay, and that can be caused when we don't have enough blood volume. Right? If we don't have enough blood volume, we can't produce blood pressure to get blood to our vital organs. Not sure where that just happened. Okay, let's see. Oh, there we go. Okay. Yeah, and so remember, the skin is a reservoir for blood, which is mostly water, right? And we also have water in the interstitial fluid. So when we have a large burn that takes up a good some large amount of our body surface, then we just evaporated a ton of our blood, right? A ton of our water. So our blood volume drops drastically. And that's what can lead to shock, right? Because our blood pressure drops drastically because we've lost blood volume. And yeah, and so this is just showing somebody in the shock position, trying to use gravity to get the blood back towards the core. Okay, so that's number one. Well, I'll write this in. So shock definition is decreased blood flow to vital organs. And that can be caused by a lot of different things, but in this case, it would be caused by that loss of blood. Okay, so that's concern number one, which is the most life-threatening right away. And then concern number two is risk of infection, right? Because we've just lost our primary barrier to the outside world, right? This is our first line of defense against all infections is our skin, right? So we're stopping stuff from coming in. So we've got lots of open area now for infection. Okay, questions on that at all? Go ahead, Faith. Yeah, definitely worse as we move along, but yeah, definitely not for first degree burns. Second degree burns, if it covers enough area, it can definitely, because that includes the dermis as well, so it can definitely lead to shock with enough area of second degree burns, but not so much first degree. Yeah, good question. Yeah. Okay, so then we've talked about blisters already, right? We've kind of already dealt with that, so we don't really need to deal with that again. But let's talk about different types of skin wounds here. Okay, so we'll talk about each of these. So different types of open wounds, abrasion, laceration, puncture, avulsion, and amputation. And then the closed wound we'll talk about is contusion. Okay, so really just want you to know how to define each of those and what they mean. Okay, so when we're talking about a laceration, it's usually a nice clean cut in the skin that a lot of times lays open, right? And if it stays open too much, then that's when we need to get stitches, right? And so laceration is a nice clean edges to it, usually from a sharp object that slices through our skin. Abrasion, right, is more of just a scrape, right? So some kind of hard surface rubbed against our skin, or we rubbed our skin against a hard surface and just kind of shaved off some top layers of our skin. That's an abrasion. Puncture wound is just like it sounds, obviously, right? We get something jabbed into our skin, a foreign object of some sort that punctures right through our skin. And then an avulsion, we'll talk about avulsion in multiple settings, but an avulsion of the skin is when a chunk of the skin is actually just completely ripped off, right? We also kind of an avulsion fracture, which means a chunk of bone is pulled off. That usually happens like a tendon pulls a chunk of bone off, or a ligament pulls a chunk of bone off. We can also have avulsions of so avulsions of the skin, avulsions of ligaments or tendons, both pulling part of the bone off. So that's called an avulsion fracture. Okay, I'll take that one off the screen. I didn't find you a real picture of an amputation. Maybe I should have, but yeah, obviously we know what an amputation is. And then a contusion is just a bruise. But I shouldn't say just a bruise, because these can be very debilitating injuries. I don't know if you follow football or any other sports, a lot of times you'll see like so-and-so is out for 2 months with a thigh contusion. You're like, the heck, you got a thigh bruise and you can't play for 2 months and he's getting paid millions of dollars, right? So what can happen with a severe contusion is that blunt force comes down and it literally smashes all of your tissues between whatever it was that was hitting you, like maybe somebody's helmet, and then your bone, right? And so it can actually tear through all of your muscle. It can tear through all underlying tissues. So it can be a very, very damaging and debilitating injury if it's serious enough. Contusion can really damage a lot of tissue underneath. And so really it's just internal bleeding, but the skin wasn't actually broken. Okay. And then last couple things, and this is just kind of extra info because students would always ask me questions on this, so I looked it up, but not something you need to know for the exam. But sunburn is, people would always ask that, like, what's actually happening with sunburn? And so what happens is those UV rays from the sun damage the DNA in our keratinocytes, okay, as well as those Langerhans cells, okay, and then this stimulates them to die, apoptosis, which causes them to destroy themselves, right? Then we get a bunch of cells that are dying. They release chemicals that stimulate inflammation in our skin, right? And then that inflammation leads to blood flowing to that area, vasodilation. That's how we get the redness and the pain, okay? And we can see this here by these kind of blacker cells are ones that have died. And then they're spilling out their contents, and that's what stimulates the immune system, causes that redness, causes that pain that we get with sunburn. Go ahead. Yeah.
When they die, do they get like
So that is more of a response of the melanocytes in your skin. And so that's actually them melanocytes putting more pigment into the other keratinocytes that are left to protect those from being damaged from the sun. So there's some kind of chemical messages that the other cells send to the melanocytes that say, hey, we need more protection for our nuclei here, because the melanin actually wraps around the nucleus like a little shield. And so that has a color to it, makes our skin darker with tanning. But it's more of a response that the melanocytes are responding to. So yeah, putting more pigment in our skin. Yeah, other questions on those? Okay, how many people have tattoos? Anybody? Yeah, we got quite a few. Almost the same number that had a relative with skin cancer, about the same, about 20% in the class. No connection. I'm not making that connection, but so this is really interesting too. The interesting part about this is the needle goes pretty deep, right? It actually goes all the way through the epidermis, okay, and down into the dermis, as you can see here, kind of in this image. So that needle's going all the way through, and then it's just kind of dumping the ink down into the dermis, right? So that is why it hurts, because it's got to go in there quite deep. But then it's not just that the ink stays there. The ink is actually engulfed by phagocytic cells like macrophages and other types of cells that are there in that area. And then eventually the engulfed ink will eventually become incorporated into the protein that the fibroblasts send out. Okay, the fibroblasts are the ones making all the proteins in that area. And so then they're just sending out different protein that kind of has this darker color to it. And so it just eventually is kind of just incorporated in as part of our connective tissue that we find down there in the dermis. And yeah, so, but then they do fade over time, right? And so those protein fibers eventually are replaced with other ones, and there's some fading, but yeah, they last for quite a while. So it's a big business, tattoo removal. Hopefully none of you guys have to want to do that at some point, but there's a lot of a very big business in yeah, people getting their tattoos removed. So hopefully you made a good decision on getting your tattoo. Just kidding. All right, guys, we're all done. Good luck in the lab today. Good luck on the exam on Friday, and I'll see you guys on Monday.